Alright, this recording takes us through the second half of the WJEC Intermediate Maths Paper 2 from November 2017. At this point we've already completed 46 out of the 80 marks, so everything that we gain from here now is a real bonus. First question's on indices, laws of indices. And what you need to remember when working with indices is that you need to have the base terms, which are the letters at the bottom of the each part. They have to be the same. So because that's a P and that's a P, it means that when we're working with the powers, we can apply the laws of indices to them. And when we're multiplying where the bases are the same, we add their powers. So what we've got here is 6 times 3, which we deal with ordinate in an ordinary way. 6 3s are 18, and then it'll be P, and it will be to the power of 6 plus 3, which is 9. So we're looking for 18P to the 9, which is there. With this one, we divide the numbers, so 3.4 divided by 13.6, which will give us a quarter. So we're looking at a quarter, and then the bases are the same, they're G's, which means now when we divide we can subtract the powers to give us 1/4 G to the 6. Now writing 1/4 G to the 6 like that is the same as G to the 6 over 4. So that's what we're looking for, and there it is. And then here we've got a combination. So on top we've got m's, so I can add those. So that's going to be m to the 3 plus 6 over m to the 9, which is m to the 9 over m to the 9. When we divide, we subtract the powers, which is m to the 0. Now anything to the power of 0 is 1. That's another fact you need to know from indices. So that's equal to 1. And if you weren't sure of that, you could just see there, well, I'm dividing something by itself. When you divide anything by itself, it goes in once. A solution of the equation x cubed plus 2x equals 91 lies between 4 and 5. Use a method of trial and improvement to find the solution correct to 1 decimal place. Okay, so this is a method that's well worth learning, because 4 marks at this high grade C, low grade B is a real bonus. I know that it lies between 4 and 5, so there's no point me trying 10 or 3. I need to go between those two values, and the most sensible place to go is halfway, so I'm going to try x as 4.5. Now on your calculator, and you may have seen me explain this in other videos, when you're going to replace an x with a number, if you imagine that the x is made up of 2 brackets that are the wrong way around, and when you want to replace those with a number, you're going to blow them apart to put the number in, and they land that way around. So what I'm saying is, wherever you see an x and you're going to put a number in, replace it with brackets. So I'm going to do 4.5 cubed plus 2 bracket 4.5. So on my calculator, open bracket, 4.5, close bracket. You've got an x cubed button, it's there next to the abs, plus 2 bracket 4.5. Exactly as I've written it. 100.125. I'm looking for 91. That's too big. So that means now I can forget all about 4.6 and 4.7, because it's going to be between 4 and 4.5. So next I'll go for 4.3. So 4.3 cubed plus 2 lots of 4.3. Open bracket, 4.3 cubed plus 2 bracket 4.3. 88.107. I'm looking for 91. That's too small. So no point me trying 4.2. I now need to go. These aren't consecutive yet. There's another one decimal place number I can check, which is 4.4. Open bracket, 4.4, close bracket, cubed, plus 2 lots of 4.4. 93.984, which is too big. So now I've got it between two consecutive one decimal place numbers. The answer, the solution, lies between 4.3 and 4.4. And I want my solution to 4.4. So one of those is going to be my solution correct to one decimal place, because that's all the one decimal place searches I can do. That is going to get you 2 out of 4 marks. In order to get full marks, you have to now apply a slightly different stage to decide which one of those you're going to work with. And in order to do that, you're going to go halfway between these two. So I'm going to test using x equals halfway between 4.3 and 4.4. If you imagine that that's £4.30 and £4.40, you go halfway between £4.30 and £4.40, you get £4.35. So I'm going to put x as 4.35 back into my equation. And work out what that is. .01 ... I don't need to round it, I can just say that's what it's looking like on the calculator, and that's too big as well. Now what that means is, if you imagine what we've done here now, on my number line I've got 4.3 and I've got 4.4. I've gone halfway between, and that gives me a number of 91.01, which is too big. That means there's no point going between those, because everything there is going to be too big. It means my solution is in between here, and any value to 2 decimal places that's in there will round to 4.3. So the solution lies between those two. Anything between those two rounds to 4.3. So x equals 4.3 to 1 dp. So what you have to remember is, once you've got it between the two consecutive values to one decimal place, you have to go halfway again. When you test that, if it comes out to be too big, it means your solution to one decimal place is the smaller value. If that worked out to be too small, it would knock out everything this side, which means the solution would be between here and here, and any value between there and there to one decimal place would round to 4.4. So that last stage is really important. It turns 2 marks into 4. Question 12. A triangular prism of length 2 meters is shown below. So it's got a triangular face like a wedge, and it's 2 meters long. Notice the units of the ends are in centimeters and the length is in meters, so we need to be careful of that if and when they ask us to find a volume. But first of all, we're working with the front part. Calculate the area of triangle ABC. Give your answer in centimetres squared. You must show all your working. Well, the area of a triangle is half base times height. So the area of the triangle would be half times the base AB times the height AC. I know AC, I don't know AB. I need to find AB. I got a right angle triangle where I know two of the sides. So this needs to trigger Pythag for you. Right angle triangle, (21, 35), don't know. So if you watch any of my Pythag videos, you know that what I tell kids to do is to square the numbers you're given first up. So I got my 35 squared, (1225), my 21 squared, 441. Now I know I need to either add or subtract those sides, those squares, and the way you decide is to look at whether you're trying to find the longest side, the hypotenuse, or one of the shorter sides. If you're trying to find the longest side, you need your output from the sum to be bigger, so you'd be adding them. If you're trying to find one of the shorter sides, you want the output of the sum to be smaller, so you'll subtract them. In this case, AB is one of the shorter sides, so I'm now going to subtract those two. So 1225 take 441, (784). And then to get it back to length from squares, I have to do the opposite of squaring, which is the square root. (28 centimeters). So I now know that AB is 28 centimeters. So the area equals a half times AB times AC. You can type that exactly as we see it if you like. So 294. And the area will be in centimeters squared. So that's the area of that face there. Part B, calculate the volume of the prism. You must give the units of your answer. Okay, on the front, the only other piece of information they give you on an intermediate tier is the volume of a prism is the area of cross-section times a length. Now a prism is a shape like that where no matter how many times you slice it, the thickness can change, but the cross-section, the face that you're cutting through, will always be identical. Once you know the area, you multiply it by the length. Well, what we have here is just that. This is a prism, because no matter how many times I slice it that way, it will have that triangular face through which I've cut. So the volume is the area of that, which we've just worked out, times the length. So that's the area of the triangle ABC times the length. But where you have to be careful is that the units need to be consistent. So because we've worked out the area in centimeters, use centimeters squared using lengths in centimeters, so that's the 294, we have to turn that into centimeters as well. So we got 294 times 200 equals 5880, and then for volume we work consistently in centimetres, so it's a cm. Area is centimetres squared. We're multiplying that by another centimetre, making centimetres cubed. So for those 3 marks, 2 marks if you get 58800, 58,800, and the final mark is for correctly writing centimetres cubed. Question 13. Find the answer to the following number problem. The LCM of 12, 18 and 24 divided by the HCF of 36 and 54. Okay, you need to know that LCM means lowest common multiple. And by multiple, I mean basically the times table is generated. So 12 multiple, first multiple is 12, 1 times 12 is 12, 2 12s are 24, 3 12s are 36, 4 12s are 48, 5 12s are 60, and so on. And we'll keep this list going. 18, 36, 18, 36, sorry, wrong one. So 18 times 2 is 36, 18 times 3 is 54, times 18 times 4, 72, 18 times, gosh, what have I got? 1, 2, 3, 4, 5, 90, 12, the next one there is 72, so I've got 2 72s there. Let's move on to 24. 24 times, gosh, 24 times 2 is 48. 24 times 3 is 72. So the lowest common multiple is the smallest multiple that appears in all 3 of those lists. So you can see there, the lowest common multiple is 72. HCF is the highest common factor. Now, the highest common factor, factors are the numbers that divide exactly into 36, and it's usually easiest to work them out by listing them as pairs. So 1 and 36, times those together, you get 36. 2, 18, 2 18s are 36. 3 12s are 36. 4 9s are 36. 5 doesn't go into 36 because it doesn't end in a 0 or a 5. And 6 6s are 36. Now, if you kept going, 7 wouldn't go into it. 8 goes into 36. I'm just going dead again. No. So the next one there would be 9, which would go in 4 times. So all you're then doing is repeating the ones that you've already got there. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, 36. Now we do the same with 54. So 1 and 54. 2 goes into 54 27 times. Does 3 go into 54? If you don't know, try it. Yes. Does 4 go into 54? No. 5 definitely doesn't. 6 into 54 goes 9 times. 7. No. 8. No, and then 9 we're back into reversal. So those are all the fact pairs, all the numbers that divide exactly into 54. So this time we're looking for the highest number that is in each list. So 1, 2, 3 are in both lists. 6 is in both lists, 9 is in both lists, 12 isn't, 18 is in both lists. So we're looking for the largest number that's in both lists, which is 18. So what they want us to do is the LCM of that divided by the highest common factor of that. So we're going to do the LCM 72 divided by 18 4. Okay, so not particularly challenging so long as you know what to do to find an LCM on a HCF. Bit of algebra. Rearrange the following formula to make x the subject. So we're going to follow the rules of equations for this. So the first thing we'll do is get rid of the bracket. 2x plus 2y equals 7y take 3. Make x the subject. What that means is you need to now treat that like an equation just by and end up with x equals. So the first thing I'm going to do, the x is on this side, is to get rid of the 2y by doing the opposite of adding 2y, which is taking 2y off. It leaves me 2x on this side. 7y take away 2y is 5y on that side. Now to get the x on its own, I have to undo the times 2 by dividing by 2. In algebra, I'd write that all over. 2's will cancel, leaving me 5y minus 3 all over 2. And that's the final line of algebra. There's no answer to it. All you're doing is rearranging it to get x equals on its own. Okay, then we've got an nth term. Now we're at in the second half of the intermediate tier, so we're well into higher tier questions here. So this may not be as straightforward as an nth term you'd be used to. You look at the differences. First difference is 3. Second difference is 5. Next is 7. Next is 9. Now a normal nth term question would be a linear one where these would all be the same number. They'd all be going up in 3s and it would be 3n rule, or they'd all be going up in 8s, it would be an 8-10 rule. When those numbers aren't the same, but their differences are the same, 2, 2, 2, 2, 2, that's telling you it's not linear, it's going to be an n squared rule. So what we do now, the positioning is just first term, second term, third term, fourth, fifth. So if it was an nth term rule, it would be n is 1, n is 2, n is 3, n is 4, n is 5, and so on. Because those aren't the same, we're going to square those numbers. We're going to do n squared. So n squared would be 1 times 1 is 1 to 3. 2 times 2 is 4 to 6. 3 3s are 9 to 11. 4 4s are 16 to 18. 5 5s are 25 to 27. So that would be an n rule. We're looking at an n squared rule, and hopefully now you can see, well, there's a jump of 2 there, a jump of 2, a jump of 2, a jump of 2, a jump of 2, which means it's n squared adding 2. So just be aware of that. If that comes up in the second half of the paper, it's likely to be less straightforward than you'd hope. Look at the differences just as you've been taught with a linear one. If the differences are the same, it's fine, you know what to do. If the differences change, but the gap between the changes are the same, it's going up in 2s, means it's not an n rule, it's an n squared rule. So rather than going up 1, 2, 3, 4, 5, we're going up n squared. 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on. And then look at what's happening here, and you can see they're going up in 2s. so it's n squared plus 2. Grade B now, okay, so if you're aiming for a C and that blows your mind, don't lose any sleep. If you think, oh yeah, that makes sense, I can remember that, then that's a bonus 2 marks. Question 15. Diagram shows 2 right-angled triangles. Okay, I'm seeing that. I know that I've already done some Pythag on a previous question. This is a trig question. 2 right-angled triangles joined together along a common side. So I've got SPQ is 90, SQR is 90, 2 right-angled triangles. And they've put on the angles for you. SQP is 38, PS is 8, so that side is 8, and QR is 15. Calculate the size of angle X. So angle X is in this triangle, and in order to find that angle using trig, I need to know 2 lengths. At the moment, I only know 1 length, so I can't progress. However, in this triangle, we have a common side. So if I can work out the length of QS from this triangle, it then gives me the 2 sides I need in the bigger triangle to work out X. So to find X, first need to calculate SQ. So let's just redraw that little triangle and put on what I know. PSQ 8, 38, and it's SQ I want to work out. So we're in trig. I need to label my sides. The opposite is opposite the angle. The hypotenuse is what the right angled box is pointing at, and the other one is the adjacent. What I see so often with students now is that the first thing they'll do is they'll write out these triangles. Which is absolutely fine, so long as you write them in the right order, the letters within them. I need now to select which one of those groupings I'm going to use when I know the opposite and I need to find the hypotenuse. So opposite and hypotenuse, that's adjacent and hypotenuse, opposite adjacent, opposite and hypotenuse is that one. What you then do is cover up what you're trying to find. I'm trying to find the hypotenuse, so that's going to be O, opposite, over sine. And sine is always linked with the angle. So the hypotenuse is the opposite over sine 38. Hypotenuse is SQ, that's what we're trying to work out. The opposite is 8 over sine 38. On your calculator, you need to make sure that that little letter says D for degrees. Mine doesn't, it says R for radians because I've been doing some A-level work. We need to make sure that's a D. So if it isn't, you need to go to Shift and Mode for setup and press button number 3 for deg, for degrees, and then that's changed to a D. I can type this in exactly as I see it. Fraction, 8 on top, sine 38 on the bottom. You can see it's forced open a bracket, so I need to shut it and then press equals. 12.99, so that's going to be 13 centimeters. So now in the triangle SQR, which I can redraw, SQR, that's my angle X. I now know SQ is 13 and I know R is 15. Label my sides. Opposite, because it's opposite the angle I'm dealing with. Hypotenuse. Adjacent. So the two sides I know are opposite and adjacent. Opposite and adjacent are in the tan triangle. And if it's an angle I'm trying to work with, then that's the letter that I cover up. So tan of my angle is opposite over adjacent. So tan of x is opposite 15 over adjacent 13. Now, to get the x on its own, I have to undo, like an equation, I have to do the opposite of tanning. Now, the opposite of tanning, if you look on your calculator, most of the functions, the opposites are above them. So tan, above it, has got tan minus 1. That's the opposite of tanning. So to get the x on its own, I'm going to do tan minus 1 of that side. Type it into the calculator exactly as I see it. Shift tan, fraction button, 15 over 13, move it out from underneath, close bracket, equals 49 degrees. It's not asking you to give it to any particular degree of accuracy. So if you look at all the measurements you're given, they're all rounded to the nearest whole number. So give your answers to the nearest whole number. Absolutely grade B work there. So again, if you can deal with trig, you should be able to make access to that. If you're pushing for a grade C and trig isn't something that you've done, then at this stage I wouldn't lose any sleep over that, or go and practice it off the topic pages in my website. Final question. All the members of the Farming Club visited the Royal Welsh Agricultural Show. They all travelled to the show either by bus or by car. None of them visited the show on more than one day. The decision to travel by car or by bus was independent of the day of the visit. A member of the club was selected at random. The probability that this member travelled by bus was 0.87. The probability that the member visited the show on the first day was 2/3. Complete the tree diagram below. Okay. If you haven't come across questions like this before, I'm not going to go through them from scratch here. I'm going to assume you know how to deal with this. If you wish to practice them, then again go to the website topics page on intermediate tier and take a look at tree diagrams there and practice them. So if you know what you're doing, you know that these little branches have to add up to the total probability. What this is saying is there are two methods of travel, bus or car, nothing else. So you're either going to be on one or the other. Total probability is 1. So this and this have to add up to 1. Take that off 1 and you get 0.13. Same thing here. First day or other day. 2/3, that has to add up to 1, so that must be 1/3. And the same here, 2/3, 1/3. Part B. What is the probability that a member chosen at random was not one of those who travelled by bus on the first day of the show? Well, the way that the probability tree works now is you work out the chances of somebody travelling by bus and on the first day would be there and there. And when you use the word and in probability, you multiply. So if you're travelling from there, bus and first day, up here, you would be doing 0.87 times 2/3. If you wanted bus and any other day, it would be 0.87 times 1/3. Down here, car on the first day, 0.13 times 2/3. Car and any other day, 0.13 times 1/3. So if the question had asked, what's the probability that it was one of those who travelled by bus on the first day? It would be 0.87 and 2/3. Now, that is the only way that you would travel by bus on the first day. So then, in order to work out not 1, you would take that away from 1, total probability. So, probability travelling by bus and on first day will be 0.87, bus and first day okay, so exactly as I see it, 0.58. So if that's the chances of them travelling by bus on the first day, then the chances of them not travelling by bus problem of them not travelling by bus on the first day will be 1 minus 0.58, which is 0.42. So there you go. That is the second half of the paper from November, paper 2, November 17.